All right, is it recording? I think so. So I guess we can go ahead and get started then. Hello, everyone. Welcome to week 8 of the fall semester and our 7th meeting of the semester. How's everyone doing? I'm sure everyone's doing fantastic. Everyone loves college and everyone loves all the work associated with it. So I'm glad we're doing that. A couple things to talk about before we get into our activity today. Dr. Finch was going to host that weather game, but we postponed that to next week because she's a little bit busy at all. She's still in the meeting though, so if you have any questions for her, that's okay. But yeah, a couple things that I wanted to share. First of all, is Dr. Finch just posted this in the Discord a couple minutes ago. It's the 2021 Virtual Student and Early Career Professionals Conference hosted by the NWA. That's going to be happening on October 24th from 1 to 5 p.m. We don't know too much about it yet. They haven't posted their schedule or like their itinerary or anything. But from what it sounds like, it's just going to be a place where we'll learn about career advice for meteorology careers, what kind of things to expect when you go into that kind of field. So I feel like it'd probably be a pretty good conference to attend. As Dr. Finch said, registration is completely free. And it's only one day for 4 hours, so it's not like you would have to take out your entire weekend to attend if you wanted to. So yeah, definitely keep that open and then keep looking at the Discord for updates as well when the actual itinerary comes out. But yeah, Anthony, did you want to talk about this weather at all?
Okay, let's give her a shot. Woo! What everyone came for, right?
Oh, well, okay. Let's see. I'll dig into one model here. We'll just look at yesterday, for example. We can actually go back, I think, a few days. It's Monday. We can go back to Monday, but I don't think much. What's that? Yeah, it's the best one to use by far. Yeah, there's a lot more bells and whistles in here than anywhere else. Let's see. That's Monday afternoon. So why we had our storms here Monday, we have this little jet streak, but you can see it's kind of meridional here, which made everything almost go pretty much upscale pretty quick. Besides that one little area, we didn't have discrete cells down near New Berlin, Illinois, which is where I was on Monday. But it merged with the line and I couldn't see anything. And then I hit a gravel road and I didn't want to get stuck. So then I just drove right through the line and I got rained on a lot. But yeah, so that was Monday. So we can kind of look forward to Tuesday, which was yesterday, which was a pretty big day in Oklahoma and the Plains. And as you can see why here, they had this digging low come through. And we can say it's digging because we have this amount of energy on the western side of this trough, which as it comes down, enters the base, it digs and makes this layman's term, makes it stronger. And so as this wave of energy is moving down and rounds that base of the trough and ejects to the northeast, we can see here at 500 millibars that we have a pretty substantial jet right here. And this right here is at 21Z, this area here. So 21Z, we can actually take a sounding over an area that did see some storms. I forgot I cannot do. Come on, give me a sounding. Why can I? Oh, it's too long to go to get a sounding. I don't know. Nope, I don't think it did. All right, so let's share the screen. Sorry, everybody. Ian messed up. All right. How do I share screen? I guess I'll do this. All right. So, oh, well, that's unfortunate. Okay. Yeah, we'll blame that one on Ian. I'm just going to go ahead and say, it's Ian's fault. And so we'll go back to what we were talking about here. And so what we can see here, Monday right here, this is kind of what caused our little scenario on this little shortwave here, which, a bunch of impulses for this past week, but as we were discussing for yesterday, this area here was the area that got hit hardest with severe weather. It could have been a lot worse for Oklahoma, and I'll actually show that in a minute, but there was a capping going on in Oklahoma, which saved them really from going bonkers. But yeah, this moved through, caused the storms this morning right here, this little wave of energy, and now it's finally off to the northeast, and we can still see a little bit of a trough here, but bridging should set back in right here for the latter part of this weekend. And so what I want to do here, I'm going to show two more things. I'll get into Ian's presentation. NWS soundings. So if I go look at yesterday, 0Z, I think it was 0Z. Maybe it wasn't 0Z. There was a sounding in here that was absolutely bonkers. Is it 9? Is it 6? No, it's probably 6. Nope, I don't know where it was. I should have looked into this, but there was a sounding in here that, okay, this one right here. So this right here, I wish the screen wasn't so kind of wonky, but this right here, now I can't get that to go away.
White space.
Oh, thank you. This right here was a sounding from OUN yesterday at approximately 9Z is what? 4 a.m.? No, maybe. 4 a.m. 4 a.m. yesterday, and they actually had tornadoes down here, but as we can see, it could have been a lot worse. This little area here, so as we have this bar here, the more to the right this is, it caps it. So what that means is effectively, this is our parcel of airline. And so our parcels of air will not be able to travel past this. This little area here is called convective inhibition or SIN. And so nothing is going to get past this unless it's elevated, but this here, not elevated convection. And so this line here, this little thing here, that's a pretty steep little cap there. But as we can see, BOCO amount of cape here. We have surface cape of 2030, mixed layer of 1677 with shear out of this world, 542, 643, 649. This photograph is a really, really good photograph conducive for tornadoes. But this little line here kind of saved that a little bit. They did have a tornado warning in the OKC Metro this morning around 5 a.m. But I don't know if it ever touched down. It might have been radar confirmed. I'm not sure. But yeah, that right there was something interesting from yesterday. And we can actually show one more thing, and I'll turn it over. We can actually look at these storm reports for yesterday and today. Where's the interactive one? Should have this all set up. So once this loads, we can actually see here tornado. Tornadoes today. Nice. So we can actually go look at. Oh, was that yesterday? Heck. All right, so this was yesterday. So we can see tornado reports all throughout the area. Just nuts day for tornadoes, for wind, a little bit for hail. And so, yeah, it was a pretty good severe weather event, but, you know, it could have always been worse besides that cape, like I talked about, not being there. But yeah, so overall, what an interesting little week. We got a lot of rain. We needed some rain around here. And these areas down here needed rain too, but a bunch of severe weather. If you want to talk more about it, stick around after class. We can discuss a lot of these up here were radar confirmed, and we discussed that in Discord last night. But yeah, so could have been a lot worse down here. They actually lucked out 2 days in a row, Sunday and yesterday. Some areas did get hit. There was some sheds destroyed somewhere over here, I think. But yeah, so they did get lucky. If this was May, it could have been a lot worse. They would have had a lot more moisture. And the Cape would have been even higher than what was for yesterday in October. But yeah, so that's really all I have. Anybody want to have any questions or add anything real fast?
I'll leave that open. I want to say a couple of things. Maybe not that part of it, but something to keep in mind is he was talking about convective inhibition here. We were talking about this cap. Something to keep in mind is that when you're looking at when storms are going to fire and stuff, if you want to have a really good severe weather day and storms to have the best potential for tornadoes, you actually do want a little bit of a cap. If there's no cap at all, then what actually ends up happening is that this theoretical parcel of air is lifted as soon as it can be. And so the storms will fire in the morning because there's nothing preventing it from going up. What that means is that there's not as much time in the day for it to be or for the environment to build up energy. And so the storms aren't going to be as strong then as if they would fire closer to 3 o'clock to 5 o'clock. However, of course, that's a double-edged sword, because if there is too much of a cap, then what might end up happening is you're not able to overcome that cap in time, and then there are no storms at all. That kind of thing can definitely ruin severe weather days for you as well. I'm sure Anthony can tell you all about that, about how caps can completely ruin an otherwise amazing day. And so what you really want is to have a little bit of an environmental cap, but for there to be an erosion of that cap as the day goes on through atmospheric mixing and through heating, obviously, to try and get the surface temperature to a point where that cap is no longer a factor and it's able to lift above it. But yeah, no, definitely a pretty active week. Not technically over yet. We'll probably see at least some thunderstorms in our area through the end of this week, and then it'll be a little bit nicer. But yeah, are there any other questions before I get into my presentation? Cool. Go ahead and get started with that then. You can see my screen, right? Yes, awesome. Alrighty, so for this week, I wanted to give a presentation on GIS. Something you'll hear from a lot of upperclassmen meteorology majors is that we are GIS minors. And there's a good reason for that, which is that GIS is awesome. But no, for real, GIS is a very powerful tool that can be used in a ton of different disciplines. And so I wanted to take this time to explain to you guys what GIS is and why I think you guys should consider studying it. Yeah, let's just get into it. So the first question to answer is, what is GIS? Well, GIS is actually an acronym, and that acronym stands for Geographic Information Systems. Okay, so what is that? Well, if you search the term Geographic Information System in Google, you're going to find a ton of different definitions depending on which company or which outlet you're getting that definition from. In my opinion, the best definition that I found was as follows. A geographic information system is any framework for gathering, managing, and analyzing spatial data. Now, I understand that that is a pretty lofty definition, but I do want to take some time in this presentation to kind of break down that definition, try to demonstrate what GIS is. And so hopefully by the end of this, you should have a better idea of what that means and what it can be used for. But yeah, just in general, GIS is a very powerful tool used in a number of different disciplines. I mean, it's used like everywhere. Basically, any discipline that you can think of that uses a map at all uses GIS. And so that's how you can consider how impactful GIS can be in the world. So first of all, the first aspect of this definition I wanted to break down is spatial data. What is it? You might be able to ask, what is so spatial about it? Basically, spatial data, it can be defined as any data that has a spatial component, which is to say that it has a value that is linked to a location. The best way to exemplify that is just to give you an example. Imagine what I would say, or what you would do if I gave you the following piece of information. 8 degrees Fahrenheit. You're probably thinking, well, what do you mean 8 degrees? What's 8 degrees? 8 degrees where? And that's the key. This piece of information on its own is kind of meaningless. It's just a temperature value. It doesn't really have any intrinsic meaning apart from just a value of temperature. It doesn't really tell you anything. However, if I were to pair it with this piece of information, suddenly it makes sense. Okay, 8 degrees in Macomb, Illinois. Can't tell I made this presentation when it was in winter. But yeah, so that's the key. This kind of data only gains meaning when it's paired with a location on Earth. And so that is what spatial data is. It has some value associated with the location on Earth. And so now you might be wondering, well, wait, isn't that just like tons of data like everywhere? Aren't those examples of spatial data? The answer is yes, that's kind of the whole point. That's why GIS is so ubiquitous. It's because there are so many examples of spatial data. I have a list of just a few examples that you might encounter in your academics or just in general in your life. Tornadoes, for example, you can't talk about tornadoes without talking about where it impacted, where it happened. People, if you ever wanted to map people, you have to know where they are and how they're distributed across space. You can talk about roads and addresses. Those are inherently spatial data. Any meteorological data at all is inherently spatial. Elevation, pressure, temperature, as I said, those don't have meanings unless you have a location associated with them. That is the spatial data part of that definition. Next, I want to kind of get into how GIS works and what you're doing if you actually do GIS. So the first step is that you have to gather the spatial data. You just have to obtain it in some way. I won't get too much into how you would actually do that. There are a number of different methods. You can take GPS points, you get weather stations, which have locations associated with them, that kind of thing. Satellite imagery is an example as well, but there are tons of ways you can get spatial data. But then the important thing is you have to manage it, which is to say that you organize it in some way. Traditionally, GIS data is organized into what is called layers. Basically, a layer is a data set, and each of those layers only contains one kind of spatial data. So for example, if you have a road layer for, let's say, McDonough County, then that layer only contains road information for McDonough County. Similarly, if you have an elevation layer for McDonough County, it only contains elevation values. That is what a layer is. And the really important thing about this is that these layers are geo-referenced, which is to say that we register them in the computer in a way that when you look at a location on this layer, it actually corresponds to a location on Earth, which means that if you put two layers on top of each other, the locations associated with them will be on top of each other because they're geo-referenced in the same way. And that makes GIS really powerful because you're able to compare data from two different locations or from two different types of data at the same location. And that's really important. So we've talked about gathering and managing spatial data so far. So now we kind of know, where things are. And that's very powerful information to know. Oftentimes you'll be able to answer questions based on knowing where things are. But oftentimes that's not enough. We're also more concerned with what the relationships between things are. How are things related across space? That's a question that GIS is really powerful in answering. And so this is the most important part of this definition, is that we use GIS to analyze, which is to say that we discover these relationships. GIS analysis is by far the most important aspect of GIS, and it's also the most complicated. And so the best way that I wanted to demonstrate that is to give you an example of a GIS analysis. There's a train that doesn't impact your guys' audio. So have any of you ever heard the story of John Snow? A couple of you have. For those of you who don't know, John Snow, basically back in the 19th century, the story goes is that in central London, there was a cholera outbreak. And there was, at the time, no medical understanding of how it was spread. They thought it was bad air, or they thought it was an imbalance of humors, that kind of thing. But John Snow, who was studying to be a physician, hypothesized that it had to do with the drinking water. But he had no proof of that, so he came up with a pretty ingenious strategy. Am I closing those windows, someone? I don't want the train to impact their audio. So what he did was he got a road map of London, and he drew on it all the locations of the water pumps in central London. And then what he did was he went to these neighborhoods that were being impacted by cholera, and he asked people, hey, does anyone at this location have cholera? And so in that way, he was gathering spatial data, in which the spatial data he was gathering was cholera cases, and then he plotted those on a map. And then the ingenious thing is that he overlaid that cholera map on top of the map of the roads and the water pumps. And he found that all of those cholera cases were centered around one water pump on Broad Street. He presented that to the London City Council, they removed the handle, and all the cholera cases eventually went away. That is one of the earliest known examples of a GIS analysis. And of course, it was conducted back in the 1800s, well before GIS was ever even a thing. But if you wanted to do a modern day analogy of it, you could say that he overlaid a road layer, a cholera cases layer, and a water pump layer, and he observed the spatial pattern that resulted from it. And so, yeah, that's kind of a demonstration of the kind of analysis that GIS can do for you. And that's the kind of thing that it could illuminate for you about the world. And that's a good synopsis of the definition of GIS, which is any framework for gathering, managing, and analyzing spatial data. So I've broken down this definition, and some of you might be like, okay, well, that's cool, but like, how useful is GIS really? Like, what could it actually be used for? The answer, of course, is a ton. And so the next part of this presentation, I kind of wanted to demonstrate for you guys how GIS is used in a number of fields that you guys might be interested in studying. And so the first one we can talk about is obviously meteorology. Most of us in here are meteorology majors after all. The thing to know about meteorology is that it basically just is GIS fundamentally. That's what it is. Dr. Finch has said before in her classes that meteorologists have been doing GIS before GIS was even a thing. And it's true. As I said before, pretty much all weather data is inherently spatial. You can't talk about the weather without talking about, where it is. It just doesn't make sense. And so we can talk about different kinds of GIS analyses that we do in meteorology. For example, creating a forecast is just a type of GIS analysis. What forecast models do is they just ingest a ton of spatial data, whether it be temperature data, pressure data, humidity data. They take in all that information, they run it through equations, and then it spits out a forecast. That is technically just an example of a really complicated GIS analysis. Now, of course, GIS and meteorology doesn't have to be that complicated. Just any general mapping purpose is involving GIS. Just any weather mapping, climate mapping, if you're mapping tornado paths, for example. Radar is an example of GIS. It gathers spatial data by sending out pulses of energy and recording that energy that comes back, and then it plots it on a map. That's what GIS is. Here on the right, I have a little example of a map that the National Weather Service office out of the Quad Cities makes every day. It's literally just a temperature map, and they auto-generate it from station measurements, and then they interpolate that into a grid which you can plot temperatures on. And it's really cool because they use the same software to make this map that we use at WIU for our program. And so you could actually learn how to make this map if you wanted to. And so I thought that was a cool example of how they use GIS and how you might use it as well. Next, we could talk about GIS and emergency management. We've talked about emergency management a little bit in club recently, and that's because it has a lot to do with meteorology. It's very closely connected to it, and so as a result, it's also closely related to GIS. There are tons of different examples of GIS in emergency management. For example, flood response. You can take hydrological measurements and you need to model the river's crest height, where it's going to be and when, so you can model where you need to send your resources to deal with it. Another cool example is of damage assessment. On the right here, I have an example of a project that the GIS Center did back in 2018 when that tornado went through Taylorville. What they did was they plotted, or they basically surveyed damage, all the damaged buildings, and then they plotted that on the map. And so what that does for us is that it shows us where that tornado trapped the town. But not only that, it also shows us how severe the damage was, so that we can get a sense of how strong the tornado was as it tracked through the town over time. As it entered town here on the south, it was obviously the strongest, and then it weakened as it went through town, probably because it was interacting with buildings, and so that slowed it down quite a bit. So that's one of those things that this analysis kind of illuminated for us. Additionally, just general disaster response, we can use GIS to know how to get supplies in an area with a damaged road network. Evacuation routing, for example, that's all done using GIS. I've done that before using GIS. I also have the example of wildfire fighting. That is also a heavy hand in that as well. We also talk about it in biology or ecology, for example. There's an interesting story. Back a couple of years ago, the biology program noted a problem where all of their grad biology students, whenever they were trying to get internships and jobs outside of the university, they were being rejected explicitly because they did not have GIS experience. And so nowadays, the grad program for biology, they actually require GIS courses. So if you ever run into a biology student here in Tilden Hall, that's why, because they're actually taking GIS courses here. There are tons of examples of spatial data in biology. We can talk about individual organisms, habitat boundaries, biome boundaries, that kind of thing. And so some examples of the kinds of questions that spatial analysis can answer is, where is habitat loss occurring? What is the territory of a certain organism? Where can we build a highway that will cause the least damage to an ecosystem? These are the kinds of questions that GIS is able to answer. I could go into crime mapping as well, and its use in LEJA. I know we have at least a couple of LEJA majors that used to be in the club. Crime mapping is the obvious example. Crime is a spatial data, and so you can map that on a map. We can also talk about 911 routing, though. Many of you don't know this, but back in the olden days of the early 2000s, the 911 systems were basically just lists of addresses in a database. And so what would happen is when you call 911, it would just look up that phone number and the associated address. It would just tell that to the operator. And that operator had to relay that to the police officer or whatever. Then they would just have to know where that is. If they didn't know where that is, then the response times are obviously going to be really bad. But nowadays, all of this is done automatically using GIS. Whenever you call 911, it puts a point on a map, and then it automatically routes whatever emergency service you need to do to that location. No relaying of information required, no local knowledge. And so this has helped reduce emergency response times quite a bit. in 911 scenarios. I'm not going to beat a dead horse too much here. There are tons of other disciplines in which GIS is also applicable. Public health, obviously, where COVID-19 hotspots, that's been really impactful for us recent years. We use it in business all the time. You know, where's the best place to open a new business? That's a question that GIS can answer, and I've done that in projects before. GIS and local governments. At the GIS Center, we work with the city of Macomb all the time, and we do stuff like this. You know, where should a new bus line go? What is the ideal snowplow route? That kind of thing. Those are the kinds of questions we like to answer. I could go on. I really could go all day about this, but I'm sure at this point you guys get it. GIS is used everywhere. It is nearly ubiquitous in a ton of different disciplines. Yeah, it's very, very useful. One cool thing about studying GIS at WIU is that you might have the opportunity to work at the GIS Center. Basically, it's just a partnership between the school, City of Macomb, and McDonough County, where they maintain and update GIS layers. And so we have a ton of different projects. I've talked about 911 before. That GIS 911 system that I talked about, we're actually building that up for the state of Illinois right now. Additionally, we maintain utility databases for WIU and Macomb. We've maintained the state of Illinois official COVID-19 dashboard. If you guys have ever looked at that, that's us. Some notable past projects as well. I've talked to you about the tornado mapping. I've talked to you about flooding. If you guys remember back in early 2019 during the polar vortex episode, the state of Illinois released an official map of warming centers in Illinois. We actually made that map. I actually helped make that map. And so that's something that we've done. One of the more fun maps that we've made before is the McDonough County Health Department web map. We have a map basically where it has a point for every restaurant in the county. And then we symbolize it based on whether or not they passed their most recent health inspection or not. Yes, and so that includes all of your dorms, by the way, all of the dorm cafeterias. And so if you're ever curious about their most recent health inspection, you can go on that map and you can see that for yourself. Yeah, I haven't checked recently, but yeah, that's definitely something you can look at. If you want to look at all of the web maps that we do have available, you can go to this website, gis.wiu.edu. We have a ton of other things as well, but yeah, it's definitely one of the more fun ones. And so to wrap this all up, we can ask the question, you know, why should you study GIS? Well, I've told you all that it's ubiquitous. You'll be using it in a ton of different fields. What I will say is that GIS and geography in general is a very fast growing industry. The last time I checked, which was I think last year, GIS was the fastest growing industry that wasn't directly related to medicine. And so that means that there's a lot of job opportunities opening up in it. It makes you very employable. Oftentimes, there are some jobs that you can get that just knowing GIS is enough qualification. And so it's a good way to get yourself employable. If you do go into meteorology, the National Weather Service does like their applicants to have some experience in GIS. I have asked National Weather Service people at DVN, that's actually where they showed me that map that they made. You know, are there opportunities for GIS people in the National Weather Service? They said yes. And so that is something that you can do to diversify your portfolio. If you're in biology, of course, as I said, most biology internships and jobs won't consider you if you don't have GIS. If you're an LEJA, it's just useful to have. In general, GIS will always boost a resume. And so that's why I do think that any young, or if you're early in your meteorology program, I do recommend picking it up as a minor. It is genuinely useful. If you ever have any questions about the GIS minor or just the GIS program in general, don't hesitate to ask me, or Anthony has also gone through it plenty, so he would also be, of course, willing to answer those kinds of questions as well. That's all for this particular presentation. Do you guys have any questions? I do have a question for you guys. So this presentation was kind of just like me explaining what GIS is, but in the future, would you guys be interested in a presentation in which I actually show you guys projects that I've actually done? Yeah.
To me right now, it just seems like a really convoluted way to say add an app to something.
Right, and that's the big thing is that when I explain it in this sort of context, it doesn't necessarily give off the idea of what things you can accomplish with it. And so I definitely think that would be good for me to give some examples of projects that I've done specifically both in school and at the GIS Center to give you guys examples of what can accomplish. So yeah, I'll put together a presentation for that in the future because I do think that's something that should be done. Yeah, that's all that I have for you guys, then yeah. Cool. Yeah, just a few different reminders. If you are in club and you haven't paid your club dues yet, I do request that you do that as soon as you can. It's not a big deal if you can't do it right now, obviously, just by the time the semester ends, we would like to have club dues in.
And also the receipts for whoever gave you money last week, like Kathy.
Yep. That's all I have for you guys. If there's anything you guys wanted to talk about after club, I will be sticking around. I can be here as long as you guys need me to. That includes you people in the Zoom call as well. But yeah, that's all. Then I guess I can call it for now, and I'll see you guys next week where we'll play a weather game. Dr. Finch. Cool.
Katie,
Yeah.
can I give you a little bit of something real quick once you're done?
Sure. Yeah.
So, I'm gonna take a try to do JS class next semester. JS one, there's JS one something.
108 probably.
So I think so. So, like, is that for the minor? How many JS classes do you take?
Yeah. So GIS minor requires a total of 18 credits,
Okay.
and GIS 108 counts for that. That's 4 credit hours by itself. So that's definitely a question.
So, how many like per? Like,